we can define that. Yeah, we can define that here. Don't worry about it, dude. It's all good. Just get something out. And then we'll make it really pretty. But I have this like inherent desire to just procrastinate about everything. And discuss things. Sometimes discussion is good, and sometimes doing it John McCormick style. Worked for him. Alright, so here we're going to take the entity and ref it. Also changes, also adds it to display. Yeah, so what's interesting about this, also updates its components. That's not... I was thinking about it. Since we handle the drawing entirely on our own, we don't have to worry about the X, Y, and Z until we have to draw it, because there are hidden objects that aren't on screen. So we could make that position way down here, but eventually we're going to have to flip them over to the top once the guy spins, the user spins the thing down. So I'm not going to worry about position until it's needed. And we just assume they don't have position. We don't need... Yeah, we don't really need... That's not true. That is not true. We need a position for each object. We're going to have events that deal with them, and we want the collision detection to work with them. So what we'll do is just have some objects way off of the screen. We need to worry about the position of the ones on the screen, basically. This is going to be fine. Just watch. We're not going to implement a position setter here, but in draw, position, and thinking too much. Okay, we'll worry about it when we get to it. So, draw self might be able to be okay the way it is. If we leave it as it is, it's a blue object. And the children go on top. So that's perfect. Children automatically get displayed on top. And they should be on top of the belt. So let's look at draw children for snakeable entity. Yeah, and look at that. We cannot do this, but we'll start there. because basically we will need to enumerate over things. But now we can define how we represent the belt position and state. So we know that there's n entities, and there's going to be a we will keep track of the middle entity with a float called middle, we'll just call it position. Okay, and this is index based m entities index based position. So of what should be in the middle. 0 e.g. 0 means 0.0 means the entity at entities 0 should be in the middle of the belt, and m entities size -1 is above, and m entities 1 is below. Yeah. Of course, there's special cases and I don't have 3. But we'll probably just do a size trick here, and we'll just wrap, you know, we'll wrap the size with a mod or something. Something like that. There is no negative value allowed. So the full range is from 0.0 to n .99999. To size plus, is that right? Size -1 is the last index. No. To size minus -0.001 or something. Some alpha. So this, I think, will allow every state to be represented. And note there's no, so this allows some loosey-goosiness with our float. And it's good to have loosey-goosiness sometimes. As long as we rely on the collision detection, we don't have to worry about actual indices, because we're using position. Is position the best word for that? Belt. There's already a position variable, so how about we call it belt state. I like belt state. State has the connotation of a discrete element. But I think it's okay. What do you call that if it's not a discrete element? Hey, it's all discrete, pretty discrete looking zeros and ones once you look at the memory. And that's the excuse they use. Okay, so what we want to draw now, we can have a pound define for the number of things we want to draw. How's that? And we can always make it an odd number. That will save us some trouble, because then we can go up and down the same amount. It's the case where we have to switch from even to odd is actually ugly. I've had to write code for that a couple times. So for now, let's just define k children draw. K num children draw. Just K children draw is good. So we do a No. I'm going to make this even simpler. What do you call that? Yeah. Pairs of children drawn after the first one. So it's always going to be one child drawn. Extra pairs drawn. And just say one. So the number of children drawn is, oops. Okay. Times 2 plus 1. I think it's pretty obvious from the first sentence, but just in case. For size ti equals 0, I less than m entities. Why did I pick such a hard word to type? Almost like a trill on the keyboard. T-I-T-I. T-I-T-I-E. Wait, T-I-T-I-E. Yeah, the number of characters repeated on that are very large. Okay. I++. So, we draw the entities. Take the entities. I'm not done with you. I'm not done with you yet. Okay. I'm gonna just do it the lazy way. So what we could do is